In the 5th lecture, we discussed about the dredging methods and equipments. We discussed about the different types of dredgers like mechanical and hydraulic dredgers. In this lecture, we will continue and take you forward for other types of dredgers which are commonly deployed in offshore operations. Other types of dredgers are essentially under the single umbrella of classification of specialized types of small size and capacity and operational rate. They are jet lifts, airlift dredgers, auger suction dredgers, pneumatic dredgers and amphibious dredgers. If you look at the jet lift dredgers, these dredgers use Venturi effect of a high concentrated pressure stream of water to draw the dredged spoil into the delivery pipe. As you understand in the last lecture, it is essential that the dredged spoil should be first loosened from its source at site and then it should be sucked or it should be transported through a pneumatic system. In jet lift dredger system, a high concentrated pressure stream of water is used to draw the dredged spoil from the settled spot into the delivery pipe. The jet dredgers fortunately has no moving parts, therefore, the blockage of wires and dock debris is minimized in this kind of operation. They can be easily maneuvered on spud cans as they are very small in size. If you look at airlift dredgers, alternatively they are also similar to jet type dredgers, except that instead of high steam pressure water, these kind of dredgers use high pressurized air. There are no moving parts in the system, therefore, no blockage to the flow system, and if at all any blockage occurs, that occurs to the minimum level of operation. Hard material cannot be dredged using this system because this can cause damage to the air suction system in the dredgers. Alternatively, you have another type of dredger which is called auger suction dredgers. They operate on same principle as that of cutter suction dredgers which you saw in mechanical type of dredgers. In this type, a mechanical cutting tool is rotary, whereas in cutter suction type the cutting tool remains stationary. Archimedean screw is placed at right angles to the suction pipe. The screw releases the material which is fed to the suction pipe when it is being entering the pipe. The auger suction advances into the cutting phase by hauling operation. It is used for very high precision cutting and dredging. You can also have pneumatic type dredgers which works on evacuator principle. It contains a chamber which is open to draw the material and water inside the chamber. The sucked material in the chamber is then pumped out with the inlet of the chamber remain in a closed position. The process is sucking and evacuation, and hence the dredging action is only intermittent because it has got to first suck into the chamber, then the chamber is closed and then it is released. Therefore, the operation cannot be continuous as it is a successive flow of sucking and evacuation. You also have amphibious dredgers. They remain operational while afloat or elevated clear of water surface. They are fitted with grabs, shovels and buckets which are similar to that you saw in mechanical type of dredgers, but of course in smaller size. You also have water injection dredgers. The pressurized water jet is applied essentially to loosen the hard material which is deposited. This is a self propelled dredger. It creates turbidity current of very high density than the surrounding water. The bed material is thus loosened and then moves with its own current into the suction tube. It is best suitable for mud and fine sand of dredge spoil. The larger applications of these kind of dredgers are seen in ports and harbors. Serious demerit of these kinds of dredgers is the voluminous discharge of a turbid water. This is a pneumatic water jetter which is having a water intake system available here, which is supplied with a self propulsion system. It has got a long ladder which has got series of buckets which has got a water jet array which keeps on pouring the water jet inside to loosen the material, and then the material is sucked up using grabber or the bucket. Now the ladder is supported from the dredger vessel by a longer hoist wire which we call as a ladder hoist wire. This is a similar dredger in operation as you see once the dredging starts and the fine sand and mud is being dredged up completely, as you see as a pictorial view. As we see, the dredgers and auxiliaries are also important. All dredgers are equipped with series of auxiliaries. They are sophisticated electronically controlled data logging systems. They are helpful in positioning the dredger, loading and recording, and station keeping the dredgers while they are in operation. Generally, the visual display unit shows the current position of the trailer, the drag head, the cutter head, the backhoe stick and the bucket when they are in operation. The depth of cutting, current dredger depth and the slopes are also possible to get displayed on the VDU as the dredging operation continues. They help in improving the efficiency and to avoid over dredging. They also help in improving the precision of dumping where strict environmental controls do exist. As we saw in the previous lecture, different types of mechanical dredgers like bucket dredger, dipper dredger. Common examples as we saw in the last lecture are clam shell dredgers. The photograph now shows you clearly that this is a clam shell bucket which is doing dredging in this operation and keep on transporting the dredge spoil into a barge as you see here. This is actually a dredger which is supplied with a self propelled engine which can be placed in position with that of spud cans. This is a grab dredger. As you saw in the previous lecture, grabs are nothing but buckets which has got two half shells which can open, then pick the spoil and get deposited in the containers. This is a clam shell dredger which you saw a video in the last lecture. How does it operate? Of course, these kinds of mechanical dredgers, though the operation has less volume of picking up the dredge spoil, but the efficiency are much superior to a parallel bucket type or a ladder type mechanical dredgers. The commonly adopted clamshell dredgers has pictures as you see here. This is a clamshell which has got two valves hinged at the center, which has a cutting edge as well as this opens and the dredge spoil is discharged. This is the photograph which shows that the clam is picking up the dredge spoil and supplied with a rotary crane which can rotate and dispose this dredge spoil from the side to the top of a barge located nearby. The bucket dredger is what you see here, has different parts of important machineries which are operating with this dredger. This is having a self propelled engine which can be supported by the spud cans where this can be position restrained while it is under operation. The bucket dredger has a very long boom and has got a winch based on which the whole operation of cycling or the swinging radius is controlled by the spud hoist as you see here. The hoisting and swinging machinery and the control house are all located in the front side of the dredger. The dredger also has a dump scow parallel to the top attached to this. Therefore, whatever spoil is being dredged from the side can be rotated and can be deposited in the dump scow here, and from the dump scow can be further transported to the deposit site as the requirements may be. Ladies and gentlemen, interestingly this figure tells you what are the important mechanical components which are present in a bucket dredger. This what you see is a bucket which picks up the spoil from the deposit. Is having a second two half shelf simple bucket which is having a cutting edge as well. It is supported by a crane hook, is suspended from a crane. So, the bucket is being lowered and pulled up as you saw in the video in the last lecture. This is nothing but a boom which can rotate practically 360 degrees, by which enabling the bucket to collect the dredge spoil around the periphery of the dredger. This is an A-frame which supports the boom as well as the hoist of the bucket. This is where we call as a control house, which is having the mechanism control through which the whole dredger can remain in operation. These are the spuds which are helping the dredger to keep position restrained when the dredger is in operation. This is the hoist and swinging machinery which is actually used to operate the bucket for dredging operation. These are the spud hoist which are controlling the movement of the spud penetration into the seabed when the dredger is under operation. In case of bucket dredgers, the excavated material which we address as dredging spoil is placed in the scows, which is otherwise called as hopper barges. These are then later towed to a disposable areas. The bucket dredgers range in a different capacity, varying from 1 to 10 cubic meter. The effective working depth is limited to only about 30 meters. This can be used in depths to 30 meter or more, but the depth is limited in terms of economical limits and the drum capacity, because as we saw in the last lecture, dredgers are chosen according to, very interestingly, the depth of operation and the type of material which is to be dredged from the site. The bucket dredger is not a self propelled system, but it can move itself over a limited area during the dredging process by the manipulation of spuds and anchors. These are all photographs showing different levels of operation of a bucket dredger. As you see, the dredger is picking up the material and it is being discharged in a specific form as it is desired. There are advantages and disadvantages of bucket dredgers. It requires only a very small operating crew. It can even dredge rocks when broken to pieces by blasting. Heavy versatile machine which is very commonly used in harbors. The disadvantages of these kind of dredgers are they are very slow moving, they are not self propelled, the relatively low production rate. The spoiling site must be directly along the side of the dredge, that is very important, otherwise it requires barges for collecting the spoil deposit from the dredges. The other alternative mechanical type dredgers which you saw in the last lecture is elaborated here is a dipper dredger. As you see, this is a dipper and a shawl which is provided along with this. This kind of dredgers can also be position restrained using spuds, as you see in the figure here. The dipper dredger is basically a barge mounted power shovel. This is a shovel connected to this A-frame, and the A-frame is connected to the hoist, and that is connected and controlled by the vessel which you call as a dredger equipment. It is equipped with a power driven ladder structure and operated from a barge type hull. A bucket is attached to the ladder which is forcibly thrust into the material, and then the material is removed. The dipper dredger in operation is what you see in this photograph here. This is the dipper, this is the A-frame which you can see the shape is A, this is the A-frame, is an hoist which is supporting the dipper. It has got a power shovel which is forced into the material for dredging spoil, then collected and then disposed of. Of course, this can also rotate, but this is actually moving through a ladder arrangement, and this is disposed of into the barge itself as a collection mechanism available in this kind of dredgers. The dipper dredgers are required to increase the digging power. The dredge barge is actually moved on a power spots if you want to actually improve the digging power. This transfers the entire weight of the forward section of the dredge to the sea bottom. The dipper dredgers have a bucket capacity varying from 5 to 8 cubic meter and a working depth of up to 15 meters. This is not a self propelled unit, but can move itself by dredging process only by a small distance by manipulating the arrangement of spuds and dipper arm. The merits and demerits of dipper dredgers are as follows. It can remove material consisting of clay, hard packed stone, sand, or even blasted rocks from the spoil site. It is used for removing old piers, breakwaters, foundation piles, etc. It requires less room to maneuver in the work area than most of the other type of dredges. The excavation is precisely controlled, therefore, there is a little danger of undermining foundation when dredging is done. The power is applied directly to the cutting edge of the bucket, which makes it possible to remove even very hard material of deposits. Salient advantages of this kind of dipper dredges are: the dipper dredger type of operation limits the volume of excess water, that is very important, because as the dipper picks up the drain or the spoil from the side, water drains off during this operation itself. So, the volume of excess water in barges as they are loaded can be minimized. The dipper dredged material can be placed in the shallow waters of eroding beaches to assist in beach nourishment parallelly. There are some limitations of this kind of dipper dredgers. It is very difficult to retain soft semi suspended fine grained material in the buckets of the dipper dredges. Scow type barges are required to move the material to a disposal area. Production is relatively low when compared to production of cutter head and dust pan dredges. Not recommended for using in dredged contaminated sediments. Ladder dredger is another type of dredger which you saw in the previous lecture. I want to elaborate the parts of a ladder dredger. You can see, yes, ladies and gentlemen, this is a ladder which is having series of buckets being fixed to it. The bottom of the bucket is what we call as the tumbler. This is a ladder, as you see in the photograph. This is a chain of buckets which is cutting, collecting and transporting, and of course, there is a hull which is controlling the whole dredging operation. It has series of buckets on the endless chain that rolls over a drum attached to a long frame which we call as a ladder. One end of the ladder is lowered, which brings the buckets into contact with the material that is to be dredged. The buckets dump by gravity near the upper end of the travel. The capacity and depth depends on operational criteria of this kind of dredgers. It is seen that these kind of dredgers are suitable up to a depth of 45 meters. The digging volume vary from maximum to 75 cubic meter per hour under an average condition of operation. It can be used for mining, but not extensively. Airlift dredges use hydrostatic pressure to raise material from the bottom into a piston like cylinder. Once the cylinder is full of sediments, the compressed air pushes the material through a pipe to a temporary barge or a disposable site directly. Suitable for removing contaminated sediments, since very little water gets mixed up with the dredged sediments in this kind of operation. Ladies and gentlemen, in these lectures of 5 and 6, we have seen different kinds of dredging operation, different types of dredgers, hydraulic, mechanical and other types of dredges, their size, their limitations, their advantages, their disadvantages and their suitability to a specific type of operation. I have a small tutorial for you in this lecture. I want you to answer this sincerely by looking at the support material attached to this lecture, which is seen in the NPSL website. What do you understand by dredging, dredgers and dredges? How many types of dredges are there? Classify them. Which dredging system do you propose based on the following? Based on the physical characteristics of the material to be dredged, based on the quantity of the material to be dredged, based on the dredging depth, based on the distance from the dredging site to the disposal area, based on the physical environment of and between the dredging and the disposal areas, contamination level of sediments and method of disposal. Of course, you must list them depending upon the production requirements available at site. I can give you very small tips as far as these two lectures are concerned to remember them. Underwater excavation is called dredging. After the initial excavation, what we call capital dredging. To establish a channel, dredging must be done periodically to keep it clear and safe for navigation. This is what we call as maintenance dredging. Once the sediments are dredged from the waterway, they are called dredged material, otherwise literature call them as dredged spoil. A dredge is a machine that scoops or sucks sediments from the bottom of waterways, or it is used to mine materials underwater. I hope these two lectures on dredging would have given you sufficient information about the methodology and equipments of operation used in dredging process. Dredging is a very important process which is continuously happening for maintaining the navigable areas in ports and harbors. We will see in the successive lecture what are the risks involved in analysis and design of offshore structures. Thank you.